we are going to discuss about signal degradation in optical fiber. Generally in communication system, so there is a major drawback is signal degradation, because some unwanted signal, it can mix with the original message signal, then finally it degrade the overall message signal. So there is a major drawback in the communication system. Here we call it a noise, a unwanted noise which can be disturb the signal. Okay, fine. Now let us see the list of content. Here the signal degradation in optical fibers, attenuation and attenuation mechanism. Let us see signal degradation in optical fiber. Now the major thing is the attenuation. Here this attenuation may be find the maximum repeaterless separation between the transmitter and the receiver, the signal attenuation. And next, signal distortion. So what will happen, the distortion in the sense some optical pulses are formed, it burdens the signal. So what will happen, this overlap between the pulses will give the aliasing effect and the information may be lost. So this is second one. The signal degradation, two way I can say, one is the signal attenuation and next one is signal degradation. So if you see here the optical system, here it produces some pulses. Here we know that we can go for amplifications. Okay, so then finally what will happen, here again amplification can reveal many stages, but these pulses will form, this overlapping of these pulses will cause the signal distortion. Here it shows the information capacity of the fiber. So it is nothing but the signal distortion. Fine. Next, attenuation. Attenuation, it's majorly, so you can say it can reduce the strength of the signal. So this is one of the important point. You can say the attenuation is a drawback of any communication system. The main thing is, so it can reduce the strength of the signal. This is very important point. So we have to minimize the attenuation. Every communication system we have to minimize the attenuation. This is very important. Okay. So the attenuation may occur. It may be the analog signal or digital signal, whatever it may be, the form it may be any form, but we can call it's a loss. Once attenuation is introduced in our signal, then we may experience some loss. Okay. Next, not only that, attenuation will cause, so because of the natural consequences of signal transmission over longer distance. Okay. So attenuation may be, it refers to any reduction in the strength of the signal. This is important point. And next one, so the signal may be any type, whether it may be the digital or analog. And next one, the attenuation will be caused due to the natural consequence of the signal transmission over longer distance. Fine. Now if we see attenuation, so let us consider the initial distance and the final distance. So initial distance is 0, the final distance is L. Okay. So here this P of 0 is nothing but the initial power and P of L is nothing but the final power. Now what will happen? See here exponentially, here this attenuation factors are multiplied with the incoming signal. So this alpha P is nothing but the attenuation coefficient. So exponentially it will increase. Exponentially it will increase and it can be productive with the power. So finally what happened, overall our signal quality will be degraded. So it may be calculated. So by using alpha dB by km is equal to 10 by L of log P naught by PL. Approximately is equal to 4.343 alpha P. So this is the attenuation calculation. Okay, fine. Now, attenuation mechanism. So what are the attenuation mechanisms in the fiber optic communication system? Generally, we know that attenuation, so it can reduce the strength of the signal. Fine. So the mechanism can be categorized into three. One is absorption loss, scattering loss, and radiative losses. Fine. Let us see one by one. Absorption loss. Here, in this absorption loss, so due to the atomic defects in the fiber material, this loss will occur. So we know that here the core, here the cladding, okay, here the fiber is, the light signal is propagating in the core area. Now, what will happen? So, due to some atomic defects in the fiber material, composition material, so what will happen? Our light signal may be absorbed. So, finally, the signal quantity will be decreased. If the signal quantity is decreased, automatically we may experience some losses. So, there is nothing but the absorption losses. Not only that, some impurities present in the material also will lead to the absorption loss. Fine. Next, scattering loss. The scattering loss is nothing but, so due to the microscopic variation in the material density. So again, here the fiber core, here the cladding, here light signal is propagating. So here there is some microscopic variation in the material density. So immediately what will happen? The light signal here can be introduced and here it can be going out. Here also a major drawback in the communication system. So here we have to maintain the proper strength, say scaling. If it is variation occurs, then what will happen? Automatically here the scattering loss will occur. Another important loss is nothing but the radiative losses. So radiative losses is based on the power loss, how the optical power will loss. So here we can categorize this, here you can call it a bending loss and core cladding losses. So these all are comes under the radiative losses. So bending loss. So here due to the bending of the fiber, some of the signal may be lost. You can call it a bending loss. So the bending may be categorized into microscopic bending and macroscopic bending. So because of this bending nature of the fiber, so we get some losses. So this is all about the radiative losses. Fine. The main thing in the signal degradation is nothing but attenuation. Attenuation is an important parameter will lead the signal degradation in the optical fiber communication system. Thank you.